So we begin with the next chapter here, which is system of particles and rotational motion. And in this chapter, in this first section, we'll focus only on system of particles, and the first topic from which is center of mass. Okay, beginning with this question. It's a very recent one, 2024. So what I'll do is for this first question, and almost in every possible question that are coming up, wherever it's required. Okay, I'll try to cover the question in three different ways. One, we'll do it in a very short way, which will not have any detailed explanations and will have only direct calculations. Second part, wherever there it is necessary, I would make sure that the concept is explained. So in this case, we'll try to go in detail with this word uniform section. What is the relevance of, what is the significance of this word uniform section? And the third part, we will discuss the detailed solution. Okay, so if you are okay with the direct calculation, maybe you can just write down the note and then just move to the next question. But if you feel that much clarity, or deeper explanation is required, you can go to the third part of this. Okay, so this is part one. We'll go to the direct calculations. So we have 1, 2, and 3. I'll try to summarize everything here. So first is uniform thin metal. So uniform thin metal, what does it imply? It implies equal mass distribution, which means in a uniform plate, the mass density, which is mass density equal to mass per unit area, is constant throughout. Which further means that if you take any two sections of the plate with the same area, they will have the same mass. Okay. Let us try to understand this explanation first, and then we'll go through the example. So when we say that the mass density, which is actually mass per, so we have sigma is equal to mass density, which is mass per area. Now in a uniform plate, this mass density, which means mass density sigma, is constant throughout. So if I consider one plate and if I divide it into four equal halves, say for instance 4 equal halves, and then assign individual mass densities for them, say sigma 1, sigma 2, sigma 3, sigma 4, then we have sigma is equal to m by a, then sigma 1 will be equal to m1 by a1, correspondingly sigma 2 will be equal to m2 by, my bad, this should be equal to m2 by a2, similarly m3 by a3 and m4 by a4. Now if the plate is uniform, then sigma is constant throughout, which means sigma 1 should be equal to sigma 2, and likewise with sigma 3 and sigma 4, right? And if we consider sigma 3 and sigma 4 alone, what can we say? If sigma 3 is equal to sigma 4, then m3 by a3 should be equal to sigma 4, which is m4 by a4. And if this condition is true, m3 by a3 is equal to m4 by a4, then if we impose another restriction here, which is if a3 is also equal to a4, then it becomes clear that m3 should be equal to m4. Therefore, it means that if you take any two sections of the plate with the same area, a3 is equal to a4, they will have the same mass, m3 is equal to m4, when the mass density sigma is a constant throughout. Okay, so that is the significance of this word uniform plate. Now if we assume this plate to be a plate of 8 kilogram mass, then every 1 meter of the plate weighs 1 kilogram, or in other words, no part of the plate is heavier or no part of the plate is lighter than any other part of the same size. Size is important. So if this is 8 kilogram plate, it simply means that this part should be 1 kilogram, 1, 1, 1, making it sum up to 8. Okay. Now, if I were to consider this plate in a different, in a different manner, say for example, if I consider this as 1 unit, okay, maybe I'll just draw it more fairly. So say this is 1 unit, unit 1, okay, and then we have another unit which is unit 2. Come on, and all these of course, for examples, right? And we have third unit like this. And so this is the fourth one. In this case, what should be the mass distribution? It should be exactly, it should be like this. Make a guess, it should be 2 plus 2 plus 2, right? Why? Because this complete mass is divided into 4 equal parts, and every meter square will have 1 kilogram. And this goes for example, okay? We're just assuming that it is 1 meter, so 1 kilogram per meter square. We're just assuming it to be. So if the density is given to us as 1 kilogram per 1 meter square, then this logic holds. Okay, right. Now, if you're clear with this part, let us now go directly into the calculation of center of mass. So what I've done is I've divided this complete figure into 3 different areas: area 1, area 2, and area 3. First, we will consider the calculation for area. First, we'll consider the calculation for area 1. Okay. Now, for area 1, the center of coordinate, the coordinate of center of mass is C1, which is x1, y1. And we know that x1, y1 is equal to, this distance is 3, this distance is 1. So if I have to write this, so we have this much of length is 3, and this length here is 1. And therefore, the coordinate of center of mass would be width by half and height by half, which is 3 by 2 and 1 by 2. And the mass of this area should be equal to 6 kilograms. Why? Would be equal to 6. Why? Because the complete mass is 10, which means this should be 2 plus 2, and this complete rectangle should be 6. Okay? Why? You can just divide it like this. Equal divisions will have equal area. So it will give me areas like this. 2 plus 2 plus 2, and if I combine that as one single mass, I'll get it as 6. Okay? Right. Now, so that's with the calculation of area 1. Now let's see what's the same calculation for area 2. So for area 2, which is highlighted here, right? Area 2, which is highlighted here, the dimensions of this area are 1 centimeter is the width, 1 centimeter is the height, and therefore the center of coordinate should be therefore the coordinates of center of mass should be 1 by 2 and 1 by 2. Then why do we have this plus here? We have 1 plus 1 by 2 because this is the center of coordinate of center of mass here, right? And every measurement we make should be made with reference to the origin, which means it is this far from the x-axis, right? And it is this much far from the my bad, to make it more correctly. So we have, this is the coordinate of center of mass, this is the y coordinate, which is equal to, see, this much distance is 1, this center of mass here is 1 by 2, so we'll have the coordinate as 1 plus 1 by 2, which is 3 by 2. Okay, and what about the x coordinate? The x coordinate is this distance over here, which is half of this, half of the width is 1, therefore this much distance is 1 by 2. Therefore for area 2, the coordinate of center of mass is 1 by 2 comma 3 by 2. Now if you do the same calculation for area 3, the coordinate of center of mass of this area is over here, right? Over here. Oops, my bad. And this is the coordinate of center of mass here. And how, with respect to the origin, how far is it? We'll have to calculate the x and y coordinate now. How will it look like? So say this much will be the distance of the x coordinate, right? Sorry, the y coordinate, which will be equal to, so let us say this much, what we have here is 1. half of height is 1 by 2. So the y coordinate becomes 1 plus 1 by 2, 1 plus 1 by 2, which is 3 by 2. Now, what about the x coordinate? The x coordinate means this distance, right? How much is that? Let us see. Up till this mark is 1. Up till this mark further is 1. So 1 plus 1 is 2. And this much length is half. So what we have is 1 plus 1, 2. 2 plus 1 by 2, which is 5 by 2. Right? Now, if you have any doubt, in the way I have calculated the center of mass and the coordinates, I have explained this in very much detail. You can follow the next, the coming solutions. Your concept will become very clear. See, I do understand that for one question it is taking somewhere around 10 to 12 minutes for the for the direct way, which I claim to be is not not detailed, and for the detailed explanation it will go somewhere around 15 to 30 minutes. But I assure you, if you spend that much time, only if you are here for the first time, if you're learning this concept for the first time, I can assure you that if you write down the notes with me, if you can write down the detailed solution with me, then every problem you do on your own, if you try to replicate the same method, things will become really clear to you. You will start feeling the confidence to solve these questions on your own. Okay, right. So now we have calculated all the three coordinates, and then we know that the coordinates of the center of mass of the composite figure will be x bar and y bar, where x bar is given by m1 x1 plus m2 x2 plus m3 x3, y bar being given by m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. Okay. Now what is m1? 6. So this becomes 6 into 3 by 2 plus m2 is 2, 2 into 1 by 2 plus 2 into 5 by 2. Okay. Similarly, for the y coordinates becomes 6 into 1 by 2, 6 into 1 by 2 plus 2 into 3 by 2, 2 into 3 by 2 plus 2 into 3 by 2, 2 into 3 by 2. Denominator being m1 plus m2 plus m3, which is 6 plus 2 plus 2, which of course is ratio, would cancel out to give the answer as 1. Anyway, so now we have 6 into 3 as 18, 2 into 1 is 2, 5 2 is 10, so 10 plus 18 is 28 plus 2 is 30, 30 by 2 is 15. 6 plus 6 is 12 plus 6 is 18, 18 by 2 is 9. So we have x bar is equal to 15 by 10 and y bar is equal to 9 by 10. And when you divide these two, what you get is x bar by y bar is equal to 15 by 9. And according to the question, the ratio of the x and y coordinates given to be is equal to n by 9, which means the value of n should be equal to 15. Okay. So like I said, if you have any problem, if you have any difficulty in understanding the calculation, the way to arrange the center of mass individually and then to find out the composite way, please go through the next set of questions, the next set of solutions. Things will become really clear to you. Yes, it may take somewhere around half an hour for one complete question, but if you spend that, I can assure you it will be worth improving your confidence, and you will see that in your coming solutions when you do it on your own, of course. Okay, so yeah, now let's try to understand what is the significance of this phrase uniform section, which is very important. It is not important for your numericals, but these kind of concepts are important when it comes to assertion reasoning, and of course, which acts as the very base for JEE Advanced. All right. Okay. Now, moving on to the next part of the solution. Okay. So now that we have completed the discussion on calculating coordinates of center of mass using x bar is equal to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3, let us now try to understand how the same is derived using the formula x bar is equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. Okay. So we know that the mass density, which is equal to sigma, is mass by area, right? Which is equal to m by a. Now we have x bar is equal to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. The coordinates of the x coordinate of center of mass. And similarly, we have y bar is equal to the corresponding terms here m1 y1, m2 y2, m3 y3, m1 m2 m3, right? Now, if sigma is equal to m by a, let me just write down that stuff as well. Okay. So, if sigma is equal to m by a, from this relation, I can write that m1 is equal to sigma 1 a1, right? Similarly, I can write m2 will be equal to sigma 2 a2 and m3 would be equal to sigma 3 a3. One more time, we have m1 replaced by sigma 1 a1. How? Because sigma is equal to mass by area, and therefore mass is equal to sigma into area. And we have m2 is equal to sigma 2 a2, m3 is equal to sigma 3 a3. So this m1 x1 becomes sigma 1 a1 x1, m2 x2 becomes sigma 2 a2 x2, m3 x3 becomes sigma 3 a3 x3. The whole upon m1 is sigma 1 a1, m2 is sigma 2 a2, and the same applies for the y coordinate as well. So instead of m1, we can replace m1 here with sigma 1 a1, sigma 1 a1 y1, a2 y2, sigma 1 sigma 3 a3 y3, so on. Okay. Now, if we assume that the plate is of uniform density, then we know that sigma 1 should be equal to sigma 2 equal to sigma 3, which means sigma 1 can now be replaced by, let us say these sigma 1 equal to sigma 2 is equal to sigma 3 can be written as sigma. So now I can replace sigma 1 with sigma 2 with sigma 3 with sigma in x bar, and similarly I can replace with and I can replace in which coordinate? In y bar, right? Okay. Now, okay, my bad. You found out the mistake. So this also should be equal to sigma, right? And now if we have sigma in both numerator and denominator, we can take sigma common out of the brackets. So I can like rewrite the entire expression like this, right? Rewrite the entire expression like this. Okay, wait, there is a minor mistake here. What is that? The mistake is that these terms should not be having sigma, right? Okay. Sorry for the minor algebraic error here. This should be sigma instead of sigma 1. Okay. Now, what is sigma by sigma? It is 1. What is sigma by sigma? It is 1. Therefore, what is x bar is equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. And similarly, what would be y1? You can write down that rule. Okay. Now, since that we have calculated x bar in terms of a1 and x1, let us now try to find out the answer for this question, for this numerical here. So all the previous calculations for the center of mass for figure 1, figure 2 and figure 3, they remain the same. The x bar coordinates x1, y1, x2, y2, x3, y3, they do not vary no matter which formula you use. But what varies here is, instead of m1, we need a1. Instead of m2, we need a2. And instead of m3, we need a3. So let us look for the calculation in detail. So this is the first figure. That is the first figure. And the length here is 3. The breadth here is 1. Or the width here is 3. And the height here is 1. Which means area will be 3 into 1 equal to 3. And what is the corresponding x1? It is 3 by 2. I'm doing the calculation only for x bar. You can do the same calculation for y bar. And let's see if we get the same answer. For the area 2, width is 1, height is 1. So the area will be a2 is equal to 1 into 1. And x2 is 1 by 2. Like I said, I'm doing the calculation only for x2. You can do the same for y2. And for area 3, we have length is 1, width is 1, height is 1. Therefore, area 3 will be 1 into 1. x3 we have calculated this earlier as 5 by 2. Now, if we have x1, x2 and x3 and a1, a2 and a3, what is x bar now equal to? X bar will be equal to a1 x1 plus a2 x2 plus a3 x3 the whole upon a1 plus a2 plus a3. What is a1? It is 3. So we have 3 into x1 is calculated already. So it's 3 into 3 by 2 plus 1 into 1 by 2 plus 1 into 5 by 2 the whole upon 3 plus 1 5, which is 3 3 9 plus 1 10 plus 5 15 by 2 by 10, which is 15 by 2 into 5, which is 15 by 10, which is 1.5, right? And if you see, this overlaps with the previous method where we use x bar in terms of m1 x1 and we get the same answer 15 by 10. Okay, so I have not calculated the value of y bar here. Try using the same method and find out the value of y bar, and if you have any doubts, please feel to get back. Okay, right. So now we discussed a solution for one question in two different ways using two different formulas. One m1 x1 plus m2 x2, and the other one a1 x1 plus a2 x2, and we have discussed in detail how did we arrive at these two formulas and the way of applying them by calculating the individual center of mass of these bodies and then trying to find out the composite figure the composite figures coordinates of center of mass. I hope that makes sense. Now that we have discussed these two methods of doing the question, let us spend some time in understanding the significance of uniform section and to find out the method of finding center of mass in detail. Okay, so those who are pretty much okay with the concept, and if you feel that you need only the numericals, then you can skip the next solution and go to the we can skip one solution and go to the next question. Otherwise, if you feel that the calculation of the center of mass is a bit, it's kind of a trouble to you, then maybe we can troubleshoot that. We can sit and understand the process in detail. Okay. Now that we have discussed about solving this question in two different ways, right, using m1x1 and m1a1, now let us spend some time understanding the significance of this word uniform, and then let's spend some more time in understanding the calculation of these individual center of masses and then combining them together. Okay, so first up is understanding the concept of uniform section. See, the term uniform section is crucial in solving the center of mass problem. Why? Because uniformity in a section of solid means equal mass distribution. A uniform metal plate means that its mass is evenly distributed over its entire area. This will allow us to treat the center of mass as the geometric center of each section without worrying about the variations in mass density. I do understand that things are not clear here. It may take some detailed time to understand this concept. Okay. So, in a uniform plate, the mass density, which is mass per unit area, is constant throughout. This means that if you take any two sections of the plate with the same area, they will have the same mass, which basically translates to this. If sigma 1 is equal to m1 by a1 and sigma 2 is equal to m2 by a2, and then if we say that the mass density is constant throughout, it means sigma 1 should be equal to sigma 2, and therefore m1 by a1 should be equal to m2 by a2, or in other words, m1 a2 should be equal to m2 a1. And in this, if a2 is equal to a1, then it should imply that m1 is equal to m2. Therefore, when sigma is a constant and when areas under consideration are equal, we can say that the corresponding masses should also be equal. M1 is equal to M2. Okay, right. Now, Because the mass is evenly distributed, the center of mass of the plate coincides with its geometric center. Now, when we say geometric center, this applies only to regular figures. So most of the questions that we see here will be focused on regular figures. This simplifies calculations because you don't need to account for variations in mass density. Now, for geometric center, we always consider simple symmetric figures like rectangle, circle, or triangles. Okay, and why actually the reason why we consider these figures are because it is easy to consider, it is easy to determine their geometric centers. Okay, for say for instance for rectangles it will be the intersection of diagonals, for circle of course the center, so on and so forth. Okay, now this geometric center will also be the center of mass when the plate is uniform in nature. Okay, so that was regarding the concept of uniform plate. Sorry, yeah, uniform plate and geometric center. Now, how do we apply these two in finding out the center of mass of the overall body? See, for that we use the composite body method. Now, what is composite body method? It implies that the body under consideration can be considered to be a composition of multiple individual bodies. For instance, this complete figure solid lamina given here can be considered as one large base rectangle, one rectangle on the top and the other on the right. So we have large base rectangle, left rectangle and a right rectangle. Okay. And by using the additive and subtractive method, which means adding or subtracting these sections, we can determine the overall center of mass. How? Let's try to understand that aspect as well. So we have x bar is equal to m1 x1 plus m2 x2 plus m3 x3 the whole upon m1 plus m2 plus m3, right? So this is what we have as the given figure. So we can write this as m1 as sigma 1 a1, m2 as sigma 2 a2 and m3 as sigma 3 a3. We already have discussed this part, right? And if all these sigma 1, sigma 2, sigma 3 are representing uniform density, then sigma 1, sigma 2, sigma 3 should be equal to some sigma, some random, say some sigma, say sigma 1 is equal to sigma 2 is equal to sigma 3 is equal to sigma. Okay, in which case these sigmas from the numerator and from the denominator can be cancelled, and what we get is a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. And what is x bar and y bar? X bar and y bar determined in this manner will be the center of coordinates of center of mass. Okay, so that's how we use the composite body method. Now, all of this is clear, but what comes to our mind is what would be different if the question would have said non-uniform? When that's where we consider the questions at the JEE advanced level and some of them at the JEE mains level as well. Now, if the metal plate had varying thickness or density, we would not be able to assume the geometric center as the center of mass. See, that's where the significance of geometric center comes into picture. So, if the plate is of uniform density, the geometric center would coincide with the center of mass. But if the given plate is not of uniform density, we would need integration or even more complex weight-based calculations to determine the exact center of mass. As in this figure, where if you see, the center of mass is not equal to the geometric center because there is no uniform distribution. Why? Because what I was trying to represent here is, say, okay, I think it won't be clear from this diagram. Maybe that will be clear from the next diagram. Let's try to. Okay, I'll come to the diagram in a while. Now, if we have to consider the differences between uniform section and non-uniform section, we discussed right now that the center of mass would coincide with the geometric center when the given lamina under consideration has a uniform section, and it may not coincide with the geometric center when the given lamina is of varying thickness or non-uniform thickness. Okay. So I hope this concept is clear, the significance of geometric center. Now, we need to understand and appreciate another concept here. And why are we doing this in this detail? Like I said in the previous solution, we are also aiming for assertion and reasoning questions, which will test your not just your numerical skills, but also your conceptual skills. One of which in this particular section is the concept of mass distribution being evenly and unevenly distributed. What does that mean? We will now focus our complete discussion on evenly and unevenly distributed mass. Let's see how. Now, if we have a uniform rectangular plate, which means here the mass is distributed evenly, right? And let us assume that the width of the rectangular plate is 4 and the height of the rectangular plate is 2 meters, and the weight being 8 kilograms. Okay. In this case, what is the total area? The total area here is width into height, which is 4 into 2 equal to 8 meters square. Right? Now, what is the mass density here? The mass density here is mass per unit area, sigma. What is the total mass? It is 8 kilogram. What is the total area? It is 8 meters square, which means the mass density here is 1 kilogram per 1 meter square or per meter square, which means every meter square area of this plate will weigh 1 kilogram. Or in other words, no part of the plate is neither heavier nor lighter than any other part of the same plate of the same size. Okay, let's revisit that one more time. No part of the plate is heavier or lighter than any other part of the same size. Okay, now if you understood this part, which is no part of the plate is heavier or lighter than any other part of the same size, try to think, is this figure combination correct with respect to, or is it possible to say that this figure represents an mass density of 1 kilogram per meter square when the rectangle is of 4 by 2 size? Will it be? No. Why? Because as we said, if we consider this to be, okay, the diagram here also becomes a bit confusing, right? Oh, my bad. I should have opted for a proper rectangle. Okay, so what I was trying to convey here is, if this is 1 kilogram meter per meter square, this will be 1 plus 1 plus 1 plus 1, which will give you only 6 kilograms. But the total weight here is 8 kilograms. So such a distinction is, such a division of mass is not possible here. But if we choose this reference, right, if we choose this reference, then it makes sense. Why? Because this is 1, this is 1, this complete width is 4, which is divided by divisions of 1 meter length. And now 1 meter square, which means this area, 1 meter square will contain 1 kilogram. So this will be 1 kilogram. This also 1 kilogram. These as well. And now if we add these 1 plus 1 plus 1 plus 1 4 times, 8 times, what we get is 8 kilograms. Therefore, such a division makes sense here. Okay. So this is how we divide the given laminas based on what? Based on the mass distribution. Okay. Once we find out the mass distribution, then we can find out the center of mass, which in this case will be the point of intersection of the rectangles. Right? Now, for a for a 4 by 2 rectangle, the x coordinate of this rectangle would be width by 2, which means if I assume this much to be the width, right, then the coordinate here, the center of mass coordinate over here, will have both x and y. Let us call that as x bar and y bar. X bar and y bar. So the x bar will be equal to width by 2 and y bar will be equal to height by 2. Okay. So if this was width is equal to 4 and height is equal to 2, then the coordinate here for center of mass would be width by 2, which is 4 by 2, 2, and height by 2, which is 2 by 2, equal to 1, 2 comma 1. Okay, I hope that makes sense. Or maybe like this. Okay, so the coordinate of which means it is this distance here represents distance from the x-axis and this represents distance from the y-axis, right? So you walk 2 units to the if you walk 2 units along the width, and then from there if you walk 1 unit along the height, that point is where the center of mass is located. Okay, now what would be the case if this was the same for a if we were to discuss about a non-uniform rectangle? See, if we were to discuss about a non-uniform rectangle, then we know that the 1 kilogram per meter square density distribution would not be the same, which means some of the area may have 1 kilogram per meter square and some of the other portions may have 3 kilogram per meter square, or some of them may have 1 kilogram per meter square and other having 0.5 or even less than that. Okay, which would make either of the sides go more heavier or more denser. So maybe the left hand side or the right hand side is more denser or more lighter. That depends upon the distribution. And what will happen in such a case? That is the point here. That is where we expect a potential, association question. Well, not at the simple level, but of course at the a slightly higher level. Now, if the center of mass, if the weight distribution is not uniform, then the center of mass will shift towards that side which is more denser. This is because more mass is concentrated on that side, pulling the balance point towards it. So if we were to analyze like this, so if this was the center of mass initial, and if we center of mass initial, in which I mean center of mass with even distribution of mass, but in the second case, if you consider that one side of the lamina is unevenly distributed, then we can say that this center of mass of even distribution will incline towards, which means we'll have somewhere over here the center of mass of uneven distribution. The center of mass will shift towards the denser side. Center of mass will shift towards the denser side. Okay, so just to compare the differences between the center of mass of a uniform versus a non-uniform rectangular plate, mass distribution is even in uniform, is uneven in non-uniform. Center of mass would be at the geometric center for uniform, and it would be shifted towards the denser region in a uneven distribution. Okay, right. Now, if we were to compare the center of mass of a uniform versus non-uniform rectangular plate, this is where we draw the diagram earlier. So if this was the center of mass of a even plate, right? Center of mass of even plate, then for an uneven distribution, it would shift towards the side where there is more mass density. So this is center of mass of even, and this represents center of mass of uneven distribution, which has shifted by this length over here. Okay, I hope that makes sense. Okay, so okay, wait. I was about to discuss something else here. My bad, my bad. Please give me a second. My bad. To summarize this, if we compare the mass distribution in uniform and non-uniform plate, in a uniform plate, the mass distribution would be common in common across equal areas, right? So this will make 1 plus 1 plus 1 plus 4 into 2 becomes 8. Whereas in non-uniform rectangular plate, there will be uneven distribution, more mass will be concentration on one side. So say this might be 3, this might be 2, this might be say 1, 3 plus 1, 6, maybe 1, and then we only have very little mass here, 0.5 plus zero point 0.5. Okay? But in either case, 3 plus 1, 4, plus 2, 6, plus 1, 7 and 8, the mass may remain the same. The overall mass may remain the same, but the distribution would be different. I hope this gives you better clarity on the idea here. Now let's see the difference between the center of mass considered to be the geometric center, which was something that I tried to do in the previous section. So if this was the center of mass of even distribution, we know that it will shift towards the denser region, maybe somewhere around here. This will be the center of mass of uneven mass distribution. And if you compare these to this point where the center of mass of even distribution was present, it means that it has shifted towards the region where there is more mass density. Now, what was the mass density? We earlier said that this was 1, 1, 1, and here it was 3 and 2 and 1 and 1. So the distribution has, the center of mass has shifted towards that region where there is more mass present. Okay, so yes, so that's the concept behind center of mass dependent on uniform thickness of the plate. Okay, so yes, now let us try to emphasize more on the numerical part to find out the center of mass of individual figures, and then how to find out the center of mass of individual figures with respect to a origin. So now that we have discussed the concept of the significance of uniform mass distribution and the comparison between uniform and non-uniform mass distribution, let us now focus completely on solving this question in a very detailed structure. Okay, so usually if you were to ask for the basic steps involved in solving this, I would say step number 1 would be to choose the origin. Step number 2 would be to find out the individual COM, and the third step would be to calculate coordinates of the overall COM, right? So this is what we have for every figure, for every question which is based to find out based on finding out the center of mass. Now, how do we approach this question? So we have been given a figure here. So here we'll use the composite body technique and using the method of addition of figures. The next set of solutions we'll discuss about composite figures, but based on subtraction. Now, how do we add figures? You will divide this complete given shape, given structure into 3 shapes, 3 composite shapes. One would be structure 1, the large base rectangle. 2 would be the rectangle number 2, which is close to which has one edge on the y-axis. And then the third figure, which again is a rectangle, the right one on the top. Okay. And origin is given to be this point here. So step number 1 is complete. Now what is step number 2? Step number 2 is to find out individual center of mass, which means we'll have to find out center of mass of figure 1, center of mass of figure 2, and then center of mass of figure 3. How do we find out center of mass of figure 1? Center of mass of figure 1 would be the jaw. Okay, before we go to center of mass, let us first convert this coordinates into the length. So for the first figure, which is the base rectangle, the large base rectangle here, the coordinates are 0, 0 and 3, 0, which translates to the length as 3 units along the width. And it is given to us that this coordinate here is 2, 1, right? Sorry, this would be 3, 1. So we have the 3, 2, right? No, my bad. We have 3, wait, did we have a mistake here? Okay, yeah, it's 3, 1. So the width here would be 1, right? So we have a rectangle which has length 3 and width 1. Now, what is the coordinates of center of a mass of a body which is a rectangle in shape of width 3 and of height 1? The center of mass of the rectangle is width by 2 and height by 2, which basically is the point of intersection of its diagonals, and by symmetry of the figure it is w by 2 and h by 2. The width is 3, so it is 3 by 2. H is 1, so it is 1 by 2. So the center of mass of this rectangular plate is 3 by 2 and 1 by 2. Now what is the second step? The second step is to find out the center of mass of this figure with respect to the origin. And how do we find it? So second step is to find out the position of coordinates of center of mass of a rectangular plate with respect to origin. Now what should come into picture? Now the picture of y-axis and x-axis should come, wherein we'll place the given figure and find the coordinate of this point here. Okay, and how will we do that? Let's see. So let us say that the center of mass of this large rectangle is C1, whose coordinates are x1, y1, and it is the position of coordinates of center of mass of rectangular plate with respect to origin, the origin being 0, 0. Now what is this point? This point is otherwise 3 by 2, 1 by 2. And since this is from the origin, the coordinates of x1, y1 would be, what will be x1? x1 will be distance, would be this distance, right? Starting from, let me just write down these values, maybe that will make more sense. So x1 will be this distance, C, 0 to a, OA. And how will you measure OA? You will measure OA like this. So this is the measure OA, right? And what will be the measure OA? The measure OA is equal to this length, which is 3 by 2. So x1 here is equal to 3 by 2. Similarly, what is y1? y1 would be this distance, right? y1 would be this distance. Excuse me, yeah. So y1 would be this distance, which is half of this height, which again is equal to 1 by 2. I know things are a bit confusing here. Yes, because we're doing it the first time, it would be. And the second figure onwards, things will become very clear to you. Okay. So what did we do so far? We found out the coordinates of center of mass of the first figure, x1, y1, with respect to origin. Okay. Now we have the second figure, which again is a rectangle of width 1 and of height 1, which means the coordinates of center of mass of rectangular plate of this plate, coordinate of mass of this rectangular plate will be again by virtue of its symmetry, width by 2 and height by 2. Width is 1, height is 1, so we'll have 1 by 2 and 1 by 2. Okay, are we done? No. Now we should be finding the coordinate of center of mass of rectangle with respect to the what? With respect to the origin. So now we will have to place the same figure and then find out the coordinates. So now we have C2, which is the center of mass of this rectangle with respect to origin. The coordinates being x2 comma y2. And how do you find out x2 comma y2? You'll have to find out x2 by looking at this distance. Let us name that distance OA. So what is OA? OA corresponds to this distance over here. So OA is equal to half of this width of the triangle, which is again 1 by 2, right? What is y2? Y2 is the distance from this axis over here, right? This x-axis over here. So it is this much distance. How do you find out y2? See, y2 is actually a combination of two lengths. One starting from this x-axis, it goes up over here. That is one length. And then we have the length over here. So maybe we can name it as ABC. So what is y2? Y2 should be equal to AB plus BC. How much is AB? We know that AB is equal to 1. Sorry, AB is equal to 1 by 2. How much is BC? The coordinate here is 1. So the length is from 0 to 1, which means it is half plus 1. Therefore, is equal to 3 by 2. Therefore, coordinates of mass of C2 becomes x2 comma y2, which is equal to 1 by 2 and 3 by 2. Thereby differentiating the center of mass of this rectangle alone, which is 1 by 2 and 1 by 2. So we have center of mass of the second figure alone being 1 by 2 and 1 by 2, and then center of mass of second figure with respect to origin as 1 by 2 comma 3 by 2. That is the difference here. Okay, right. Now I know some of the things which were not clear in the first section, first figure, are clear to you now. But now you have some other problems which were not earlier present, and both of them will become clear in the third figure. Let us see how. So we found out the center of mass of first figure, which is x1 y1, of second figure, the second rectangle x2 y2, and what is left to find out is x3 y3. How do you find out x3 y3? Again, we have a rectangle with w is equal to 1 as the width, height is equal to 1 as the height. So coordinates of mass of center of mass of a rectangular plate by virtue of being a symmetrical figure will be its geometric center, which is the point of intersection of its diagonals in this case, which is w by 2 and h by 2, which is 1 by 2 and 1 by 2, right? And this is the center of mass of the third figure, but not with respect to origin. And how do you find out with respect to origin? So now we have center of mass of third figure, which is with respect to origin. How do we find that? See, x3 would be this distance, right? Let me name that. So we can write this as O, A, B, and C. So x3 is the sum of OA plus AB plus BC. How much is OA? OA, this complete length here is 1. It is given in the question. AB again is equal to 1, which is given as well. How much is BC? BC should be the x coordinate of the center of mass of this figure, which is 1 by 2. Therefore, it becomes 1 plus 1 plus 1 plus 1 plus 1 by 2, which is, so this complete distance OC becomes 1 plus 1 plus 1 by 2, which is 2 plus 1 by 2, which is equal to 5 by 2. So the coordinate of x coordinate here becomes 5 by 2. Now let's see what happens with the y coordinate. So let us say this is CD. So what is the y coordinate? What is y3? Y3 is the distance of this point C from the x-axis. So from the x-axis, if we measure, we see a couple of lines here. Which are they? We can see one line which starts from D till over here. Maybe we call it as E. And then we have another line which starts from E to C, right? And how much is D to E? D to E here is 1. And how much here is CE? CE is half of this width, which is 1 by 2. Therefore, if I were to write what is CD, CD is equal to CE plus ED, which is equal to half plus 1. 1 plus 1 by 2 is 3 by 2. And the coordinates therefore are x3, y3 is equal to 5 by 2, 3 by 2. Now we have all the given values. Now we have determined all the three center of mass. What? Center of mass of the individual figures with respect to the origin, which gives us x1, y1, x2, y2, and x3, y3. Now what can we do? Now what we can do is we can find out the value of the masses of this figure. So if you have given, if you have written notes for the previous solution, then we have very clearly stated that for equal areas, the masses will be equal when the given plate is uniform in nature, which gives us the mass of the larger rectangle as 6, the smaller as 2, and the smaller as 2. So the left and the right hand top side of the rectangles will have 2 kilogram mass, and the bottom large rectangle will have a mass of 6 kilogram. Okay, so we have m1, m2, m3, x1, x2, x3 corresponding y1, y2, and y3, which means we now have all the required inputs for calculation of center of mass of the combined object, which is m1 x1 plus m2 x2 plus m3 x3 by, sorry I missed this here, should be by m1 plus m2 plus m3. What is m1? 6. x1 is 3 by 2, so we have 6 into 3 by 2 plus m2 is 2, x2 is 1 by 2, 2 into 1 by 2 plus m3 is 2, m3 is 2 into x3 is 5 by 2, so it is 2 into 5 by 2 by m1 plus m2 plus m3 is 6 plus 2 plus 2, which gives us the value as x bar is equal to 30 by 2 by 10, which is, wait, 6 into 3 is 18, 18 plus 2 is 20, 20 plus 10 is 30, 30 by 2 by 10, which is 15 by 10. Okay. Now, similarly, what would be the y coordinate? Y coordinate of the center of mass of the combined figure will now be equal to m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. 6 plus 2 plus 2 is 10 in the denominator. m1 is 6 into, okay, maybe to make sure that you don't get confused here, I'll just erase out x1 now, because we don't need x1, right? All we need is y1, y2 and y3. Yeah. So m1 into y1, 6 into 1 by 2, m2 into y2, 2 into 3 by 2, m3 into y3, which is 2 into 3 by 2 again. So we have 6 plus 3 into 2 is 6, 3 2 into 6, 6 plus 6 is 18, 18 by 2 is 9, and what we have y bar is equal to 9 by 10. Therefore, the coordinates of x bar and y bar are 15 by 10 and 9 by 10 respectively. So the ratio of x bar and y bar becomes 15 by 10 by 9 by 10, which is equal to 15 by 9. And if you read the question, what we've been asked to find out is the center of mass of the coordinate is given to us as n by 9, and therefore the value of n should be equal to 15. Okay. So let me just summarize the steps here. So fix the origin. That should be step number 1. Find out the individual center of masses. Calculate the individual center of masses position with respect to origin. With respect to origin, you then have x1, y1, x2, y2, xn, yn, and then you can find out the formula for x bar, apply the formula for x bar, y bar, which will be equal to m1 x1 plus m2 x2 etc. divided by m1 plus m2. Okay, so that was all the ways of looking at this question. I think we did a very short explanation, and then we tried it using the density method, second one the area method, and third one using the mass method. And we've seen not just the direct application of the formula, we also seen the derivation, the way we have derived these formulas. So that marks the end to this question. Now we have the second question in JEE Mains 2024, which is based on displacement of center of mass. Let's go through that now. Now we have a question that is based on center of mass of a system of particles, and usually the flowchart of these kind of questions becomes visualizing like this, assigning the origin, calculating the distance x1, y1 and x2, y2, and then finding the coordinates of x bar, y bar. But the formula we know m1 x1 plus m2 x2 by m1 plus m2. Now I have a question for you here, which is based on the selection of origin. So with reference to the questions based on center of mass, calculating the center of mass of a system of particles, origin selection is really important. In this question, there are two masses, and therefore there can be many origin to be selected. But with the most logical ones would be choosing M1, M2, and COM as three different cases of origin. So the question is, which one will you choose? Will you choose M1 to be the origin, or M2 to be the origin, or COM? And if you choose these three separately, what would be the difference? How will that influence the final answer? Okay. Now the question here says that we have two masses, M1 3 kilogram, M2 2 kilogram, are placed at a certain distance. M1 is moved, so this M1 is moved towards the center of mass with a distance of 2 centimeter. The center of mass remains the same. And in which case, how much should the M2 move towards the center of mass so that the center of mass remains the same is the question. To solve this, what we need to understand first is, what is center of mass? See, center of mass in its most simplest terms is the balance point of the system. Okay. Now, when the system is said to be in a balanced condition, we know that there are two masses and this whole mass is said to be concentrated in the center of mass. But when one mass moves towards the center of mass, the system will now become unbalanced unless the other mass moves too. Okay. To restore this balance, the second mass must move in a way that keeps the center of mass in the same position. And what way is that? The center of mass remains unchanged if the weighted displacement of one mass, look at that phrase, weighted displacement of one mass is balanced by the weighted displacement of the other mass. What is weighted displacement? It basically means m1 delta x1. m1 weight representing mass, delta x1 displacement. Okay. And this leads to the equation minus m1 delta x1 plus m2 delta x2 is equal to 0, where delta x1 represents displacement of the mass m1, which is given to us as 2 centimeter, and we have delta x2, which is equal to displacement of the mass m2, which now has to be found out. Now, yes, I do understand some of you might be surprised with this equation. We'll come back to that point later. Now let us try to visualize the given scenario. So we have, this is before this diagram here represents, let me just write it down. So this diagram represents before displacing the masses, okay, and this represents after displacing the masses. And this mass here is m1, this is m2, previously m1 and m2, okay. So this was the previous position. Now for the ease of a calculation, I will choose this yellow dot to be m1, okay, and blue dot here to be m2. So what has happened? M1 has been displaced by a distance delta x1 towards the center of mass. M2 therefore has to be shifted towards the center of mass as well by a distance of delta x2. Now if you observe here, I would take M1 to be 3 kilogram, okay, and M2 to be 2 kilogram. And if you see, the length delta x1 and delta x2, how would you compare them? Is delta x1 greater than delta x2 or the other way around? Okay, think of it and try to find a logical solution for that. Now we have the equation minus m1 delta x1 plus m2 delta x2 is equal to 0, and therefore minus m1 is 3 kilograms, so this becomes minus 3 in delta x1 is given as 2 centimeters plus 2 in delta x2 is equal to 0. So for delta x2 is equal to minus 3 into 2 is minus 6, transposing is plus 6 by 2 is plus 3. And therefore, in a system of particles mass m1 given, the distance moved should be 3 centimeter. Okay. Now the question here comes is, how did we arrive at this equation? What is the logic behind that? Well, that is where the significance of choosing the reference point comes into picture. How? Let's see that next. So now we'll discuss about this formula here, which is m1x minus m1 x1 plus m1 delta x1 plus m2 delta x2 equal to 0. And how did we arrive at this? But before we go into directly deriving this, something more important to understand is the significance of choosing a reference point or an origin while calculating problems based on center of mass. So we know that the center of mass, which actually is a point in a system where the masses of the entire system can be considered to be concentrated. For a two mass system under consideration, we know that the center of mass x bar can be written as m1 x1, right, plus m2 x2, the whole by m1 plus m2, right, where m1 and m2 are the respective masses of the first and the second body. What is x1 and x2? See, x1 and x2 here represent the distance, right? X1 and x2 represent the distance or the respective positions with respect to a origin. So the next question comes, if there is an origin in respect of which the distance are calculated, where should this origin be located, or what are the possible locations of this origin? So when the origin is said to be the center of mass, it is then the equation minus m1 delta x1 plus m2 delta x2 holds, which clearly means that there can be other origins as well. Which all are they? Origin can be either at mass m1, which means you can consider this to be the origin like this, okay, y-axis and x-axis. Or what you can do is you can consider y-axis, x-axis, and this to be the origin. If not, you also have one more case. So this is center of mass and x-axis and y-axis like this. So there are three possible ways to consider origin. Let us go through one by one. So if we have origin to be the mass at m1, or rather placing, if we place m1 at origin, which means if you keep it like this, right, then we have m1 center of mass and m2 along the x-axis where m1 is placed at the origin. And then we are supposed to find out the center of mass. Let's see how. So this is what the graph looks like. m1 is placed at origin. Therefore, the coordinates of m1, which is x1, y1, should be equal to 0, 0. m2 is placed at B. The coordinates are x2, y2. And A is the coordinate of center of mass with center coordinates labeled as x bar, y bar. Now the question is, what is the value of x1, y1? Since x1, y1 is placed at origin, x1 should be equal to 0 and y1 should be equal to 0. That makes sense? Simple. But what is x2, y2? See, if I assume that these two objects, or sorry, not objects, if these two particles O and B, that is m1 and m2, are kept at a distance r, then what is the value of x2? Then x2 should be equal to r, right? What is y2 then? Y2 is the y coordinate of this point. This point B is on the x-axis. Any point on the x-axis, the y coordinate will be equal to 0. Therefore, y2 should be equal to 0, which means this coordinates becomes r2 comma 0. Pause yourself here, draw this on your own, place these particles in the x-axis, and then try to write the coordinates on your own. Things will become really clear then. If you have a doubt, you can come back. And we know that the coordinates here are x1 equal to 0 and y1 equal to 0. x2 is equal to r and y2 is equal to 0, right? y2 is equal to 0. So, if we have these coordinates, we can then write the equations for x bar and y bar, which we have m1 x1 plus m2 x2 divided by m1 plus m2. And okay, let us first write out m1 x1 plus. What is x1? x1 is 0. So what is m1 into x1? m1 into 0, which means this part of the fraction vanishes, right? What is x2? x2 is equal to r. So we have m2 divided by m1 plus m2 whole into r as the coordinate of x bar when the object m1 is placed at origin, right? But then what is the coordinate of y bar? Sorry, what is the y coordinate here? Since y1 is equal to 0, we can say that y1 is equal to 0 implies m1 y1 is 0. Similarly, m2 y2 is 0, which means this complete fraction becomes 0, or y bar is equal to 0, right? So therefore the coordinates are x bar y bar is equal to m2 m1 plus m2 into r and 0. Therefore we can say when m1 is the origin, x bar is equal to m2 divided by m2 plus m1 into r. All right. So by symmetry, can you tell me what will be the origin, what will be the x coordinate when the mass m2 is placed at origin? Exactly, it should be m1 divided by m1 plus m2 into r, right? Now, when we fix m2 to be the origin, all the measurements have to be based on this m2, right? So all the other positions are calculated relative to this m2 equal to 0. That you can do it on your own, I do understand, but some of us may find it difficult. So I'm just trying to, trying to cover that as well. If you want, you can just go through the next derivation and you can fill the table. I think that will summarize this complete solution here. But if not, if you want to see that calculation in detail, stick on. So this time, what do we have here? M2 is at origin. Maybe I just write it down here. So we have M2 is placed at the position B, which is considered to be the origin, right? And then we have M1, which is placed at A with coordinates x1 comma y1, M2 with coordinate x2 comma y2. Center of mass C, center of mass is placed at C. Oh, well, it occurs at C with the coordinates x bar comma y bar. All right. Now let's see. What is the coordinate of B? B is x2, y2, yes, but where is B placed? B is placed at the origin, which means x2, y2 coordinate should be equal to 0, comma 0, right? So x2 should be equal to 0, x2 should be equal to 0, and y2 should be equal to 0. Now what is x1? x1 is the coordinate, x coordinate of A. y1 is the y coordinate of A. Since y1 is a point on the x-axis, because m1 is placed in the x-axis, y1 is a point on the x-axis, and any point on the x-axis, the y coordinate of that point will be equal to 0, right? So let me just write down these values over here. So y1 is equal to 0. What is y2? y2 is 0 as well, right? So y2 is 0. y2 is also equal to 0. What is x2? x2 here is 0. x2 is also, I'm really sorry for the technical glitch here, something wrong. Yeah, okay, 0. But what is x1? See, x1 is the distance, this distance, right? Distance AB. We know that the object are kept at a distance of, r from each other, which means the coordinate of A should be equal to r. Am I correct here? Or is there a mistake that I made? Yes, I did make a mistake. Why? Because these points over here are on the positive x-axis, whereas the particles lying to the left of this are on the negative x-axis. Therefore, the coordinate here should be equal to, x1 should be equal to minus r. Right? So x1 here equal to minus r. Now what is m2 into 0? m2 into 0 is 0, which means this fraction will vanish. So m1 into 0 plus m2 into 0, 0 plus 0. So this complete fraction is 0 now. And all what we have is, I will just write it down one more time. So x1 is now equal to, m1 divided by m1 plus m2 into r, but what should come into picture? Negative. And what is y bar again? Y bar is equal to 0. Okay, so what is x bar? X bar, oh wait, I have a mistake here. So x bar should be equal to minus m1 into r divided by m1 plus m2 when m2 is considered to be the origin. Now comes the most important point here, which is choosing the center of mass itself as the origin. Now here we know that since center of mass is the origin, x bar should be equal to 0 and y bar should be equal to 0 as well. But what's the significance of this calculation? Let us see that first. See, if we were to understand that x bar, which is equal to m1 x1 plus m2 x2 by m1 plus m2, similarly y bar are the coordinates of center of mass, which is now kept at origin, then this value should be equal to 0. This value should be equal to 0 as well, right? So we have from this, what is x1? x1 is the x coordinate of A. x2 is the x coordinate of B. Now since both of them are kept at a distance r, let me introduce another variable to differentiate this. So let us say r1 is the distance between center of mass and A. r2 is the distance between center of mass and B. In which case, what is x1? x1 is r1. What is x2? x2 is r2. What is y1? As in the previous case would be 0. As in the previous case, y2 will also be equal to 0. And therefore, since y1 and y2 is equal to 0, this complete fraction is now equal to 0. Therefore, y bar is also equal to 0. But what about m1 x1 plus m2 x2? m1 x1 plus, oh yes, you got it correct. I did make a mistake here, right? Which is r1 is not positive. r1 should be negative. Why? Because m2 is now, which is the position of B, is along the positive x-axis, whereas A is placed along the negative x-axis. So if we rewrite this equation, what we get is m1 into, right? What we get is m1 into, what is x1? x1 is minus r1 plus what? Plus we have m2 into, what is x2? x2 is plus r2, and what is this equal to? Equal to 0. And therefore what we get is m1 r1 is equal to m2 r2. Okay, so that's how we get these three cases. When m1 is at the origin, expression of center of mass is m2 divided by m1 plus m2 into r. When origin is chosen to be m2, then the x bar is m1 into r divided by m1 plus m2. And when it is center of mass, then we know that x bar comma y bar is equal to 0 comma 0, and therefore m1 r1 plus m2 minus m1 r1 plus m2 r2 is equal to 0. Okay, so that was the concept behind this. So this is the most important the calculation of origin based on center of mass. Now I do understand that we have not discussed the solution based on these three cases. Now the next three solutions, right? Those will be one, calculation of the same change in displacement based on m1 to be origin. Two, calculation of the displacement in m2 considering m2 to be the origin. And three, center of mass itself as the origin. Okay. So now we'll solve this question by directly using the formula x bar is equal to m2 by m1 plus m2 into r. So we've been asked to find out the change in the displacement of mass m2 when m1 is moved by 2 centimeters. Now, as we discussed in the previous section, all of these calculations will vary according to the choice of your origin. So in this case, given a 2 mass condition where m1 is equal to 3 kilogram and m2 is equal to 2 kilogram, 3 and 2, I have considered m1 to be the origin. Okay. So when we fix m1 at x equal to 0 and measure all the distances relative to it, the position of m2 is then measured from this origin. Okay. So let's try to see the detailed version of this formula. How did we arrive at this? So if we were to put these given m1 m2 into a origin into a graph, we have a as the position of m1. I'm sorry, I should have mentioned it here. So we have m1 center of mass and m2, right? So we have m1 which is placed at a. So the position of m1 is always written as a in this example. The position of m2 is referred to as b. The position of center of mass is correspondingly referred to as c. The coordinates of m1 wherever mentioned is x1 y1. Coordinates of m2 irrespective of which the origin is mentioned as x2 y2, and the coordinates of center of mass of this system system consisting of m1 and m2 is referred as x bar y bar. The distance between a and b, which represents the distance between m1 and m2, is taken as r. Now we know that by the formula for center of mass coordinates, x bar is equal to m1 x1 plus m2 x2 divided by m1 plus m2. Now the question comes, what is x1 and x2? So if you see, x1 y1 represents the coordinates of a, and where is a placed at? A is placed at origin. Therefore the coordinates here would be 0 and 0. Since m2's coordinates are x2 and y2, m2 being r distance away from m1, b being r distance away from a, the coordinate x2 should be equal to r. And since b is placed right on the x-axis, the y coordinate here should be equal to 0. Therefore, y2 is equal to 0. Now, if we have x1 y1 equal to 0 0 and x2 y2 equal to r comma 0, what is x bar y bar? m1 x1 plus m2 x2. x1 is 0, right? So m1 into x1 becomes 0 plus m2 into x2 becomes x2 is r plus m2 into r. So what we get is m2 into r divided by m1 plus m2. Now y1 is 0, y2 is 0 as well. So what we see here is m1 y1 plus m2 y2 becomes 0 plus 0. So y bar is equal to 0. Therefore, we can say that this system can be reduced. Excuse me. So this system can be reduced as one with two bodies, two particles A and B, with the center of mass of A and B being located at M2 are divided by M1 plus M2. Okay. Now let us go to the question. The particle of mass M1 is moved towards the center of mass through a distance 2 centimeter. In order to keep the center of mass of the system at the original position. So let us first consider this towards the mass, moving the system towards the mass. So towards the center of mass. So we'll first analyze what is that moving implies in the graph. So when we have the object, when we have the particle A with mass m1 moving towards center of mass. So we have mass m1 here, it moved towards the center of mass C by a distance of 2 centimeter. It is given that the center of, it is given the question that m2 will also move, right? M2 will also move. So we will have to consider the relative positions of A and B after this movement. So I have drawn two diagrams here, two graphs here, one which is before, the other which is after. Okay. Now before we have the positions of M1 as A, M2 as B. Okay. After moving, we have the positions of M1 as A dash and M2 as B dash and center of mass as C dash. Okay. So what are the coordinates of A1? X1 dash, Y1 dash. Coordinates of B dash, X2 dash, Y2 dash. Now, what is the value of X1 dash and Y1 dash? See, since this particle is moved 2 centimeter along the positive x-axis, the coordinates of x1 dash here should be equal to 2. And since A dash is on the x-axis, the y coordinate should be equal to 0. Therefore, y1 dash is equal to 0. Similarly, we have B moving towards the center of mass. Therefore, B moves a distance towards the center of mass, say x. So what will be the coordinates of B dash? It will be r minus x comma 0. So you may have a doubt here. So let me just take you through the example, the calculation part here. See, when B is shifting towards the center of mass, right? When B is shifting towards the center of mass like this, when B has shifted like this, the new coordinate is actually the length of this segment B dash. So we can say that x2 dash, it should not be B dash, it should be this length O B dash. Why? Because we are measuring every length with respect to the origin O here. So x2 dash is actually equal to OB dash. And from the figure, from the geometry of it, we can say that OB dash is actually equal to this complete length OB minus, right, OB minus this small length BB dash, right? What is OB? Is the distance between origin and B, which is actually the earlier distance between A and B, which is R. What is BB dash? We don't know. That's the unknown value here. So BB dash is equal to X. So what is X2 dash? R minus X. Okay. In this graph, if we write down this findings here, so we have x2 dash is r minus x and y2 dash is 0. Now what can we find out? Now we can find out the coordinates of c dash, which is x1 dash, which is x bar dash comma y bar dash, right? But what is given to us in the question? It is given that the center of mass of the system is at the original position, which means this C dash is equal to C. And what is the value of C? It is M2 by M1 plus M2 into R. So we can say that x bar here is equal to m2 by m1 plus m2 into r. Now, just to make sure that you get the concepts clear, let me just detail that portion one more time. What is x bar dash is equal to m1 x bar dash plus m1 x1 dash plus m2 x2 dash by m1 plus m2, right? What is x1 dash? It is 2. What is x2 dash? We found out to be r minus x. Now, what is x bar dash is equal to? Is equal to x bar, because the center of mass has not changed, which is equal to m2 by m1 plus m2. Okay. Now, just to make sure that just to declutter this. This is what primarily the question means. The new coordinates c dash, right, and the x coordinate of that, which is x1 dash, which is x bar dash, is equal to 2m1 plus m2 into r minus x, and that c dash is equal to c, which means the corresponding x coordinate should be equal to 0, should be equal. And if we equate the corresponding x coordinates, 2m1 plus m2 into r minus x is equal to m2r. m1 plus m2 will cancel from both the sides. Now 2m1 plus, if you can, 2m1 plus m2 into r is rm2, m2 into x is minus xm2 is equal to m2r. Now what will cancel here? rm2, m2r will cancel. So what we get is 2m1 is equal to xm2. We transpose minus xm2 here. So 2m1 by m2 is equal to x. Given in the question that m1 is 3 kilogram, m1 is 3 kilogram, m2 is 2 kilogram, 2 by 2 is 1, so the value of x is equal to 3, and therefore the mass m2 should move a distance of, my bad, this is not 2 centimeters, should move a distance of 3 centimeters. So the primary thing here is to understand this calculation. This graph here that we have overlapped with the previous one, wherein the positions were A at O and B here, C dash is at the same position, right? If you are able to understand this graph and the calculation, things will become really easy. Okay, so now that we've done the question based on considering M1 to be origin, what will be the next task? Would be to solve the same question using M2 as the origin. So let's now try to solve this question using the origin as mass M2. So we have already derived the equation as x bar is equal to minus m1 by m1 plus m2 into r. Yes, I do understand this, but some of us may be here for the first time. So let's have a quick discussion about how do we arrive at this equation when mass m2 is the origin. So while we consider this setup, when I say origin, what I mean is this is the plus y-axis. We have the minus y-axis over here. This is negative x, positive x, and obviously this is the origin. So when we say m1 is at the origin, m2 is at the origin, this mass is placed at the origin like this, and so is m1. So now we have m2 at origin and m1 along the x-axis. Surely if this is the setup, the center of mass should also lie along the same axis, which is along the negative x-axis, right? And if that is the case, what can we say about the coordinates of m1 and m2? Say they are a and b respectively. A representing x1, y1, b representing x2, y2. What is the coordinate of a? X coordinate of a, x1. What is that measure? Since a and b are at a separation of r, this measure should be equal to r. So we can say x1 is equal to r, but since it is on the negative x-axis, I can say that x1 is equal to minus r. x2 comma y2 equal to 0. Why? Because both of them are in the x-axis, and any point on the x-axis will have its y coordinate as equal to 0. Using this, if we write the equation for center of mass as m1 x1 plus m2 x2 by m1 plus m2, x1 is equal to minus r, x2 here is equal to 0. So what we get is m2 into 0 is 0, m1 into minus r by m1 plus m2. Okay. Now it is given in the question that A is displaced by the mass m1 is displaced by 2 centimeters. So this is what happens in the displacement, and we assume that B is also displaced by some distance x, which that we don't know. All right, and the new center of mass C dash is x bar dash comma y bar dash, A being x1 dash comma y1 dash and x2 dash y2 dash. Okay, if that is the case, what can we say about the coordinates of, now we don't need A and B, now we need only A dash and B dash. What can we say about the coordinates of A dash and B dash? A dash will be x1 dash y1 dash, correspondingly C dash will be x1 dash comma x bar dash comma y bar dash. The coordinates of the x coordinates of A dash and B dash will be x1 dash and x2 dash. What is x1 dash? Minus r plus 2. What is x2 dash? Minus r. Now you may have a doubt here, so let's just confirm. Let's just draw one more diagram to make sure that all your doubts remain clear here. So we have the y-axis, x-axis, negative x-axis, right? X coordinate of A dash, which is x1 dash, is actually the distance OA. OA dash. OA dash is equal to OA minus AA dash. Let me just draw one more figure to explain you that. So this complete length is OA, right? So OA minus AA dash will give you OA dash. What is the measure of OA? Is the distance between the initial distance between M1 and M2, which is equal to R. And what is AA dash? AA dash is 2. So what we get is R minus 2. But since this is along the negative x-axis, we'll have to take the coordinate as minus R minus 2. Similarly, B has moved. Why? Again, why? Because all these measurements are made with respect to the origin, and since these points lie on the left side of the origin, these points are taken to be negative. Now if we consider B has moved from origin to B dash. We don't know what distance it is, which is OB dash. Say it is equal to x. All right. So that's how we arrive at these values here. In which case we can write down x bar is equal to m1 x1 dash plus m2 x2 dash by m1 plus m2. x1 dash is equal to minus r plus 2, and x2 dash is equal to minus r. My bad, it's not minus r. It is some unknown value, say minus x. Should be equal to minus what? Minus x, right? Now, according to the question, it is said that in order to keep the center of mass of the system at the original position, the particle of mass m2, so the center of mass of the system is still at the original position, which means the new position represented by x bar dash should be the same as the original position, which is represented by x bar. Therefore, minus m1 into r by m1 plus m2 should be equal to m1 into minus r plus 2 plus m2 into minus r by m1 plus m2. m1 by m1 plus m2 by m1 plus m2 is 1, right? Now again we have a mistake, right? This should be equal to not minus r. This here should be equal to x, right? So this is m1 into minus x. This becomes minus x m2. So this here wouldn't be equal to Rm2. This here should be equal to xm2, and therefore xm2 will be equal to 2 into m1 divided by m2. According to the question, m1 is equal to 3 kilograms, m2 is 2 kilograms, so 2 by 2 is 1, and therefore we get the answer as 3. So, well, let me just check if that is the given question. So yes, so m1 is 3 kilogram, yes, 3 is correct. M2 is 2 kilogram, yes, the correct option is distance should be moved by a distance of 3 centimeter. Okay, so we did the same question using m1 as the origin, first using the direct formula, then using m1 as the origin, then m2 as the origin. Now let us see the center of mass as the origin. So we have solved this question using m1 as origin, m2 as origin as well. Now let us see the third option and the final option, which is considering center of mass to be the origin and calculating positions of m1 and m2 relative to the center of mass. And since center of mass is the origin, the coordinates of center of mass, which is x bar comma y bar, would be equal to 0 comma 0, right? And if you were to understand the diagram with y-axis, x-axis, origin, and what is present at the origin, the center of mass center of mass C is present at the origin, having the coordinates x bar comma y bar, right? And what is A? A is the location of M1, which has the coordinate x1 comma y1. What is B? B is the location of mass M2, which has the coordinate x2 comma y2, right? Now what is the value of x1? The value of x1 is the distance between A and center of mass, which we assume to be r1. Okay, and the distance between center of mass and B, we assume that to be r2, where the complete distance between them is r. Hope that makes sense. Let's see that one more time. Distance between A and B, or in other words, distance between masses m1 and m2 is r. Distance between m1 and the center of mass A and C is r1. Distance between center of mass C and m2, that is C and B, is r2. So x1 would be minus r1. Why? Because m1 is placed along the negative x-axis, and m2 is plus x, which is m2 is plus r2 because m2 is placed along positive x-axis. So if we calculate x bar from this expression, what do we get? X bar is equal to 0. Why? Because it is at origin. So 0 is equal to m1 x1 plus m2 x2 by m1 plus m2. So we have here m1 x1. What is x1? It is minus r1. My bad, I have written this. This should be m1 x1 plus m2 x2, which actually is equal to m1 into minus r1 plus m2 into what is x2? X2 is plus r2. So when this is equal to 0, m1 plus m2, when we transpose this, that also becomes 0. So what we have is m1 x1 is equal to m2 x2, or in other words, what we have is m1 into r1 is equal to m2 into r2. All right. Now this is not what the question is all about. The question is asking us to find out the distance moved by B when A is moved by a distance of 2 centimeters. So when mass M1 is moved by a distance of 2 centimeters, the position of mass M1 changes from A to A dash. And we have to find the position of the change in position of B, say from B to B dash. Okay, so now we have two different set of positions. One which is A dash, the other which is B dash. A dash is the new position of mass m1, B dash is the new position of mass m2. Coordinates being x1 dash, y1 dash and x2 dash, y2 dash respectively. Now what would be x1 dash? Okay, I think it is better to see an example here. So let us say this is the origin. Okay, this is minus x. We're talking about r1, and if this object present m1 present at minus x, if it moves 2 centimeter towards the center of mass, what is the new position? It will be minus 6 plus 2, which is equal to minus 4, right? So this new coordinate is basically minus 6 plus 2. And if this location is not specified, that becomes minus r plus 2 or minus r1 plus 2, right? So similarly, we have here the earlier position was minus r1. Since it has moved 2 units towards the center of mass, that becomes minus r1 plus 2. Correspondingly, since B is moving towards the center of mass along the positive x-axis, the earlier position of B was R2, the new position would be R2 minus, not x1, it is some random value x. Okay, so you may have a doubt here as well. Let us try to understand that part. So say this is the origin, okay, and we have the position of the original position of mass m2 at B. Now m2 has shifted some position along the x-axis. We don't know what value is that, some along position along the x-axis, which gives us the new value as B dash. Now say if this B was equal to 6, and if x was equal to 2, what is B dash equal to? B dash will be equal to 6 minus 2, which is equal to 4. Simple. Similarly, if the position of B is equal to R2, what will be B dash? B dash will be equal to R2 minus X. Alright? Now pause the solution here. Watch this one more time if you can. And write down a couple of examples on your own. Things will become really clear because we need these calculations based on origin, especially the ones based on center of mass origin, many a times in the coming set of questions. Okay. So we derived two values of the coordinates, which is x1 dash as minus r1 plus 2 and x2 dash as plus r2 minus x1, not x1, this is again x. Okay, keeping these coordinates in mind, what is x bar is equal to 0? Why? Because it is still at the origin. It's given to us as my m1 x1 plus m2 x2 by m1 plus m2. And why is it still at the origin? Because it is given in the question that the center of mass is at the original position. And what is the original position? The original position is C. What is C? Origin 0, 0. So C dash, which is the new position, C, which is the original position, both of them are equal to 0, 0. Therefore, x bar, y bar, both cases are equal to 0. So I can equate x bar is equal to m1 x1 plus m2 x2 by m1 plus m2. x1 here is, from the graph, it is minus r1 plus 2. x2 here is r2 minus x. Now when we open the bracket, m1 into minus r1 becomes minus r1 m1 plus m1 into 2 becomes 2m1, m2 into r2 becomes r2 m2 minus x m2. So what I'll do is I'll just transpose the negative terms towards the LHS. So we have r1 m1 plus x m2 is equal to 2m1 plus r2 m2. But from the previous discussion on x bar, which is the original position, we have found out that m1 x1 is equal to m2 x2. What is x1? R1. So m1 r1 should be equal to m2 r2. One more time, from the previous discussion, we have m1 x1 is equal to m2 x2. Therefore m1 r1 should be equal to m2 r2, which means this r2 m2 can be replaced by m1 r1, and therefore these two terms will cancel. So what we get is 2m1 is equal to x m2. Therefore, x is equal to 2m1 by m2. Value of m1 is equal to 3, m2 is 2, so 2 by 2 is 1, and therefore the value of x is equal to 3 units. Alright, so that's is the way to solve this question using center of mass as the origin. Okay, now we have another question based on center of mass. This time it's on the calculation of center of mass of a triangular body. Oh, well, not exactly a triangular body, but a body which resembles a triangle. And we'll try to see 2 to 3 different methods to arrive at the solution for this question. In the meanwhile, you can, invest more time in understanding the way these coordinates are calculated. Okay. All right. So let's move on to the next question now. Okay, so now we have another very simple question that is based on finding the x bar and y bar, that is the x and y coordinates of center of mass. Center of mass of a system of particles. Sorry, my bad. So now what's given in this question is, we've been given a triangle, right? We've been given 3 identical spheres of each of mass 2m, which are placed along the sides of a triangle, say triangle A, B, and C, such that the mutually perpendicular sides are placed at origin. Okay, taking point of intersection of these 2 sides as origin, right? So we have ABC, triangle ABC, right angled at A, and this point A is taken to be the origin. So we have what do we have here? We have triangle AB and C, and we need to put A into this origin here. So if we place the given setup into this graph, this is what we get. Now that we have the setup, what can we do? Now that we have the graph, what can we do? We can assign the values of x1, y1, x2, y2, and x3, y3, where these are the corresponding positions of the 3 masses 2m, 2m, and 2m at each corner of the right angle respectively. Now, what is x1, y1? See, since this is at the origin, x1, y1 has to be 0, 0, right? Now it is given in the question that the other sides are 4 meter each, which means AC should be equal to 4 meter and AB should be equal to 4 meter, right? So if AB is equal to 4 meter, then what should be x3? X3 therefore should be equal to 4, and y3 should be equal to 0. Why? Because there's a point on x-axis. Now if AC, right, if AC here is equal to 4 meter, what would be x2? X2 is a point on the y-axis, therefore it is equal to 0. And y2 will be equal to 4. Why? Because AC equal to 4. So now we have got the coordinates x1, y1, x2, y2, and x3, y3. In which case, what is x bar of center of mass? It is m1 x1 plus m2 x2 plus m3 x3 the whole by m1 plus m2 plus m3. Now given the question that these 3 masses are same, which is equal to 2m, so I can take 2m common from the numerator, which means the numerator transforms to 2m into x1 plus x2 plus x3. The denominator becomes 2m plus 2m plus 2m is equal to 6m. x1 is equal to 0, x2 is equal to 0, and x3 is equal to 4, which means x bar becomes 0 plus 0 plus 4 by 3, which is equal to 0 plus 0 plus, right, we have 4 by 3. Now, this is the case with x bar. How do we calculate y bar? The calculations goes the same. Y bar is equal to m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. The mass, all of the masses are equal to 2m, so that becomes 2m into y1 plus y2 plus y3. y1 is 0, y2 is 4, y3 is 0, so that becomes 4 by 3. Now the question here is, the question is to find out the value of root x. So the task here is not to find out the center of mass. But since we have x1, y1, x2, y2 and x3, y3, and the corresponding x bar and y bar, what can we write about the position vector of center of mass? The position vector of center of mass or COM can be written as x bar COMI plus y bar j. What is x bar? 4 by 3. What is y bar? 4 by 3. So what is vector r is equal to? 4 by 3 I plus 4 by 3 j. What is modulus of vector r? That will be equal to root of x square plus y square. What is x square? 4 by 3 square. What is y square? 4 by 3 square. So what we get here is root of 2 into 4 by 3 the whole square, which can be written as root of 2 into root of 4 square by 3 square, which is root 2 into 4 by 3, which can be written as 4 root 2 by root 3. And according to the question, the vector of the magnitude of the position vector is 4 root 2 by x. While comparing these two expressions, what can we say? X is equal to 3. If the value of x is equal to 3. Now there is another way. Well, it's not actually another way. It's just a different approach to to solve this question, which is based on centroid of a triangle. Now, there is another way to approach this question, which actually is to apply the concept of centroid. And this is applicable only when the given masses are equal, condition number 1. And of course, the coordinates, the masses should be placed in a triangular coordinate. I'm sorry, in the shape of a triangle. And one more condition could be applied when one of the intersecting coordinates are placed at the origin. So if these conditions are satisfied, we can use this approach, where the centroid, the coordinate of centroid represents the coordinate of center of mass, which is given by x bar is equal to b by 3, which is this length by 3, and y bar is equal to h by 3, which is this length. So maybe we can write this as O, A, and B. So OA by 3 and OB by 3. And if we have x bar and y bar, we can therefore say that the vector representing the center of mass, which is RCOM, right? RCOM can be written as xi plus yj, which is b by 3 I cap plus h by 3 j cap. Okay. Now, I do understand that some of us may find the concept of centroid and the application of it into this question a bit difficult. So, even though this is a very simple question, I would like to spend some more time just to make sure that all the doubts are clear, and that even some of us who find it difficult, they get the concept pretty clear. Okay. So, what is a centroid? It's a geometric concept that represents the average position of all the points in a shape, which closely resembles the definition of center of mass or the balance point. So think of it as a balance point of a shape if it were made of a uniform material. For example, if you could balance a triangle on the tip of a pencil, the point where it balances perfectly would be its centroid. As I said, almost a similar definition for center of mass, right? Very simple. Now, centroid is a concept not just for triangles. Centroid is a concept that exists for a lot of figures, regular and irregular figures. When it comes to centroid of a triangle, it is defined as the point of intersection of medians. Now, what is median? Median, we know, is a line drawn from one vertex of the triangle to the midpoint of the opposite sides. So a triangle has three medians, and the intersection point and the point of intersection of these three medians is what we call as the centroid. Okay, and if the corresponding coordinates are x1, y1, x2, y2, and x3, y3, the centroid x bar comma y bar or x bar comma y bar, which represents the coordinates of center of mass, can be written as x1 plus x2 by 3 and y1 plus y2 plus y3 by 3. All right, I hope that makes sense. Now, if we were to understand this question based on the approach of centroid, it goes like this. We've been given a triangle. Let me just name this. So we have O, A, and B. right? And for a right angle triangle with vertices A, O comma O, B, okay, yeah, B we have B comma 0, which is 4 comma 0, and C 0 comma H, which is 0 comma 4. The centroid is given by 0 plus B plus 0 by 3, which is x1 plus x2 plus x3 by 3, and y of centroid, which is y bar, is given by y1 plus y2 plus y3 by 3. Okay, so if we were to write the values here according to the question, this value B here is equal to 4 by 3, sorry, B is equal to 4, and this height AB is equal to 4 as well. So we have x bar is equal to B by 3 and y bar is equal to H by 3, and therefore the position vector of center of mass RCOM can be written as x I cap plus y j cap. X is 4 by 3 I cap, y is 4 by 3 j cap, and if this is the vector that represents center of mass, what is magnitude of that vector? Magnitude of vector R can be written as, and how do we have this? If we have vector R is equal to xi plus yj, what is magnitude of vector R? It should be equal to root of x square plus y square, which represents 4 by 3 square plus 4 by 3 square, which is 4 into root 2 by root 3, or which is equal to 4 into root 2 by root x according to the question, 4 into root 2 by root x, and therefore the value of x is equal to 3. So centroid can be used only when, you can use it otherwise as well, but when you have one of the intersecting origins at points at origin, and when you have the masses as equal, you can use this approach. All right. Okay. Now another question that's based on determining the concept of center of position vector of center of mass. So this is a very simple, in fact, a very straightforward question based on the topic of vector representation of center of mass. So we've been given two masses, which is mass 1 kilogram and 3 kilogram, with the respective position vectors as I plus 2j plus k and minus 3i minus 2j plus k. We know that the position vector of the center of mass for system of particles is equal to m1 r1 plus m2 r2, where r1 represents the position vector of, well, I think this whole divided by m1 plus m2, my bad. Okay, so r1 represents the position vector of mass 1, right? R1 represents the position vector of mass 1, and R2 represents the position vector of mass 2. So m1 is 1, so we have 1 into I plus 2j plus k, and 3 into minus 3i minus 2j plus k. So I minus 3 into minus 3i is minus 9i, 3 into minus 2i is minus 6j, sorry, 3 into minus 2j is minus 6j, 3 into k is 3k. I minus 9i is minus 8i, 2j minus 6j is minus 4j, k plus 3k is 4k, the whole divided by sum of masses 1 plus 3, 4. So this gives us minus 2i minus j plus k. Now what is the question? The question says the magnitude of position vector of the center of mass of this system will be similar to the magnitude of vector. So basically we've been given 4 vectors and we've been asked to find out magnitude wise which of them will be the same. So if we find out the given vector as minus 2i minus j, which actually is the vector of center of mass, the position vector of center of mass, then we can say that magnitude of the position vector of center of mass will be equal to root of minus 2 square plus minus 1 square plus 1 square, which is equal to root of 4 plus 1 plus 1, root 6. And if we compare the given options a, b, c and d, the magnitude of this vector given in option D would be root of 2 square plus 2 square plus 1, 4 plus 4 plus 1, which is 9. See, root of 2 square plus 2 square, which is root of 8, root 14, and therefore the only option left is option A, which gives us root of 1 square plus 2 square plus 1 square, which is root 6. Therefore the correct option here would be option A. So now we have found out the position vector of the center of mass. Now let's spend some more time, just some maybe 3 to 5 minutes, to understand what is this implies physically. See, we know that the center of mass is the balance point of a system, right? Or it can be said that it is a weighted average of all the positions of the respective masses. Now, when we consider a two mass system, okay, if both objects have equal masses, the center of mass is in the midway. But if one object is heavier, the center of mass will shift towards that object, the heavier object. Now, why do we use vectors? Because in 3D space, we need vectors to track x, y, and z, all the three coordinates. And we know that the corresponding position vector of center of mass will be given by m1 r1 plus m2 r2 by m1 plus m2. Again, we are specifying only a two mass system. So, when we consider mass 1 at r1 and mass 3 at r2, what did we derive the value of vector rcom as? Rcom was derived to be minus 2y, right, minus j plus k cap. Now let us try to understand the relationship between r1, r2 and rcom. So we know that the center of mass will always be closer to the heavier mass. Now, when we say that center of mass is closer to the heavier mass, it is applicable along the x, y, and the z direction as well. Which means the x coordinate of the center of mass will be closer to the x coordinate of the heavier mass. The y coordinate of the center of mass will be closer to the y coordinate of the heavier mass, and likewise with the z direction. Now, if we were to write r1, r2, and r center of mass and analyze the x coordinate and y coordinate separately, the x coordinate of r1 is 1, the x coordinate of r2 is minus 2, and the x coordinate of center of mass is the x coordinate of r2 was minus 3, and the x coordinate of rcom is minus 2. So compare these x coordinates. The center of mass is closest to the r2, which is the heavier mass here, right? So the mass, this mass is, so r1 is of 1 kilogram mass and r2 is of 3 kilogram mass, right? Now, so say this is 0, 1, 2, minus 1, minus 2, and minus 3. The position of r2, the position of the position of r1 is over here. This is r1, right? Or this is mass m1. Where is mass m2? Mass m2 is at minus 3. This is where mass m2 is. And where do we find center of mass? Center of mass is over here. This is where center of mass is located. So the center of mass is located closer to the m2, which is the heavier mass. Okay. Now, why are we discussing these concepts after solving the question instead of just solving the MCQ? Why are we going one step ahead of this? here is to make sure that we are ready for a question which is based on assertion and reasoning, which comes out of maybe which can come out of these concepts, or maybe these out of these these tables, or any such question that can be put up in the form of assertion and reasoning, which is not just about solving MCQs. It is also about understanding the given statements and the concept behind it. I hope that makes sense. So yes, now moving on to the next question, which is a typical question based on both integration and physics, based on continuous mass distribution. So this question is basically about a non-uniform mass distribution or a variable mass distribution. So, well, both of them actually are not the same. There exists a minor difference between these two. But anyway, almost all the questions that we were doing so far were based on the concept of constant mass distribution. This time we have a non-uniform mass distribution, which is given to us as a function of x. Lambda is equal to lambda 0 into 1 minus x square by L square. Now, for our convenience, let us say lambda is f of x. Okay, so lambda as a function of x, we'll just convert that to f of x, and lambda 0 will be replaced by b. So what is f of x is equal to b into 1 minus x square by L square, and this f of x is actually the linear mass density. This is the linear mass density, which is actually mass per unit length. Given that f of x is the mass per unit length, we know that the x coordinate of center of mass, or x bar is equal to x bar is equal to integral 0 to L x into f of x dx by integral 0 to L f of x dx, which actually corresponds to the uniform distribution formula, wherein we have x bar is equal to, sigma xi mi by sigma mi. Now see, the rest of this is purely integration, right? Excuse me for a second. Yeah, so it's purely integration. So we have numerator and denominator. We can evaluate them separately. So we have integral 0 to L x f of x dx is equal to, we have this complete derivation here, which gives us the value numerator being equal to bl square by 4. So we have numerator and denominator. Numerator is bl square by 4, and 0 to integral f of x dx, which is in denominator, can later be evaluated, which gives us the value as 2bl by 3. And when you divide these two, right, what you get is 3l divided by 8, and therefore x bar is equal to 3l divided by 8. And given the question that the value is 3l by alpha, so when you compare 3l by 8 by 3l by alpha, what we get is the value of alpha is equal to 8, then therefore the value of alpha is 8. So this is primarily what the question is all about. Now we will definitely come through, come back and analyze the overall process of, the complete process of integration here. But before that, the concept behind the question, which actually is the thing that we should be able to understand here. So it is given in the question that lambda is equal to lambda 0 into 1 minus x square by L0. So lambda is equal to lambda 0 into 1 minus x square by L square. So this lambda given to us is actually a function of x. So this is lambda of x. Why x? Because x 1 minus x square by L square. So you might be wondering, why not L and not x? That is where the understanding of the question becomes really important. Length is L, the complete length is L. So we have a rod assuming to be AB, whose length, the complete length is L. Okay, and it ranges from x equal to 0 at point A to x equal to L at point B. So what is lambda x? Lambda x is the linear mass density, which means the mass per unit length. So this lambda equal to lambda x is the linear mass density. What is x? X is the distance from A. So we're measuring this distance from A, or it can be defined as a location of a small element. So this is a small element with mass dm. I have to write that as well, with mass dm. So x represents the location of this element with mass dm. Now comes, what is lambda x dx? Lambda x dx. Okay, so lambda x is, the unit is m by l, right? Lambda x, the unit is m by l. So what will be lambda x into dx? It will be m by l into l. So l by l is 1. So what we get is m, which is the mass. So lambda x dx represents the mass of a small element. All right. Now this visualization is the key to understand the question in a much deeper way. There's this figure over here. Now we are not done. There's something more interesting that comes out of this value here, which is x bar is equal to 3l by alpha. Let us go through that as well. Well, we actually have derived that it is 3l by 8, right? So let's try to understand what does it mean physically. So if we consider this equation, f of x is equal to b into 1 minus x square by l square. This equation along the rod from A to B will have the minimum value at x equal to 0 and the maximum value at x equal to L. So f of x at x equal to 0 is f of x equal to 0, which is b into replacing x with 0, 1 minus 0 square by L square, which is equal to b, which is the maximum mass per length. Okay. Now, at x equal to L, we have f of x at x equal to L is f of x equal to L, which means replacing x by L. So we have L by L is L square by L square is 1. 1 minus 1 is 0, which becomes 0, which is the minimum mass per length. Mind you, we didn't say that the mass is 0. We said that the mass per unit length is 0, which means this rod AB is very dense near A, and as it goes towards B, the mass per unit length decreases and it almost approaches to be 0 at the maximum length L. Okay. Now, if we consider, why is this analysis important? Because if you consider mass, this rod over here, the maximum mass is closer to x equal to 0 and the minimum mass is closer to x equal to L. So this basically means that this rod here is denser, right? It is denser at A and it is lighter at B, corresponding positions at A, x equal to 0 and x equal to L. And this actually represents the concept of, those who have learned it in solid mechanics, this represents the concept of tapering beams, right? And the significance of larger bending moment in tapering beams, something that we'll discuss in solid mechanics. Now, how does it make, how is it relevant when it comes to discussion of center of mass? See, if we consider M1 to be the denser mass, and if we consider M2 to be the lighter mass, then the center of mass that we have calculated here is equal to the x coordinate of central mass is x bar is equal to 3l by 8, right? And again, we come to the conclusion that the center of mass is always closer to the mass which is denser or which is heavier. Why? Because here m1 was greater than m2 and therefore center of mass will be closer to m1. Now, okay, some of us may find it out here. How do you identify 3l by 8? So what is 3l by 8? 3l by 8 implies if you divide this length between m1 and m2 into 1, 2, 3, 4, 5, 6, 7 and 8 equal parts, then we have this position 1, 2, 3, this much position. This will be 3 by 8, right? This will be 3 by 8, the position of center of mass. I hope that makes sense. So yeah, so that is what I wanted to share about this question here. So a very beautiful question that actually correlates both your mathematical skills and your physics skills, the concepts in physics. Okay, now let us see the integration part. Okay, in the previous discussion, we quickly glanced through the integration here, and we found out the value of x bar, and we also discussed in detail the concept of this equation given here, and we analyzed this equation f of x is equal to b into 1 minus x square by l square, and we found that the rod is denser at end A and is rarer or lighter at end B, which means along the length AB, along the length x equal to 0 to x equal to L, the mass distribution varies from maximum mass per length to minimum mass per length, and since we have x square by L square, we have a quadratic reduction of mass from A to B, right? And we also discussed that the center of mass is closer towards the denser side and is far away from the lighter side, which marks the concept of tapering beams. Since that we've discussed the concept in detail, let us now focus on the mathematical part of this, the integration part. So lambda x is replaced by f of x here. So lambda x is equal to lambda 0 becomes f of x is equal to lambda 0 is replaced by v, so it becomes b into 1 minus x square by l square. Okay. Now why? Just because for convenience. So x bar, right? So we have x bar, which is equal to the x coordinate of center of mass is given by integral of 0 to L x f of x dx by integral 0 to L f of x dx. Now this actually corresponds to the equation x bar is equal to sigma mi xi by sigma mi. What is sigma mi means, or what is 0 to integral f of x dx means? This denominator here represents the total mass of the rod, that is m. And what does the numerator represents? The numerator represents the mass moments. Numerator represents the mass moments, which is given by sum of individual masses into the distance they are placed within the mass. Okay, so let's now try to understand the integration of the numerator part here, which is 0 to integral x f of x. It's a very straightforward integration actually. What is f of x? It is b into 1 minus x square by l square. So when you have x into b into 1 minus x square by l square, okay, before we go into the integration, some of us may have a doubt regarding the limit 0 to L. Now how do you understand that? For that, we have to come back to our diagram, which is here. So when we say that the linear mass density is a function of x, linear mass density is a function of x. So we have linear mass density is a function of x, which means linear mass density will have its lower limit, at the lower limit of length, which is x equal to 0. And linear density will have its upper limit when the x is at the distance is at the maximum limit. So lower limit is at x equal to 0, correspondingly upper limit is at x equal to L. Very simple stuff. I hope that makes sense. Okay, so the limit here becomes 0 to L. So x into 1 becomes x into x square becomes x cube. Since b is a constant, I take that out of the integrand here. So what we have here further is b into integral x dx minus integral x cube by L square dx. L square is a constant here. Why? Because here L represents the length of the rod, which is a constant, right? Length of the rod is a constant. So b into integral of x is x square by 2, varying from 0 to L. L is a constant, so we have 1 by L square outside the integrand, it becomes 1 by L square into integral of x cube is x to the power 4 by 4, varying from 0 to L. Then x to the power L by 2, varying from 0 to L, becomes L square by 2 minus 0 square by 2. X to the power 4 becomes L to the power 4 minus 0 by 4, which gives us L square by 2 minus L to the power 4 by, okay, so we have L raised to 4 by L raised to 2 is equal to L raised to 2 by 4, which is 2L square by 4 minus L square by 4, which gives us b into L square by 4. So x bar, or the x coordinate of center of mass, is integral 0 to L x f of x dx by integral 0 to L f of x dx. We have so far integrated the evaluated the numerator, which is equal to bl square by 4. Now let us focus on the denominator. So denominator again is a very straightforward integration. F of x is b into 1 minus x square by L square dx. B is a constant, can be taken out of the integrand. So that becomes b into integral 0 to L 1 minus x square by L square dx. This integrand can be split into two halves. Integral 0 to L 1 dx minus integral 0 to L x square by L square dx, which gives us b into integral of 1 is x varying from 0 to L, x square is x cubed by 3 varying from 0 to L. L is a constant, so I'll take it out of the integrand, 1 by L square. Then what we get is, applying the limits, x becomes L minus 0, L cubed by 3 minus 0 cubed by 3. That becomes L minus L by 3, which is equal to 2L by 3. So that becomes 2LB by 3. Now we have found out both the numerator and the denominator. That becomes BL square by 4 by 2BL by 3, which is BL square by 4 into 3 by 2BL. Now let me just confirm this. So B by B is 1, L square by L is L, 4 into 2 is 8, so we get 3L by 8. And according to the question, the mass density is, sorry, the center of mass is 3L by alpha m, right? So distance of center of mass from end A is actually the x coordinate of the center of mass, which becomes 3L by alpha. Now comparing these two, we have alpha is equal to 8. Okay, so we did discuss in detail the significance of this equation and the derivation for the same. So maybe I'll just leave out this for you to take it down. So although this is a very simple integration, I would definitely suggest that you take down things with me for one time, practice it a couple of times, and then speed comes naturally to you. Speed in solving the problems. Okay, now moving on to the next question, which is based on semicircular ring. Okay, center of mass of a semicircular ring. Okay, so now this is a question based on the center of mass of a uniform semicircular ring, which we know if the semicircular ring is placed such that the center of the ring, if it overlaps, right, the center of the ring, if it overlaps with the origin, or in other words, if the center of the ring is placed at the origin, we know that the x coordinate of the center of mass, which is equal to x bar, will be equal to 0. Why? Because the figure is symmetric with respect to y axis, and the y coordinate of the center of mass, which is y bar, will be equal to 2r by pi. So essentially it means that the center of mass is located somewhere over here, right? So this is y bar. Oh well, that would be too much. 2r by pi with something over here. Yeah. So we have 2r by pi as the y bar, right? Now it is given to us in the question that the position of center of mass is given by 0, xr by pi, then the value of pi, and then the value of x is equal to, oh my bad, this is not value of pi, this should be value of x. So we have 0, xr by pi. Now when you compare the coordinates of x bar, y bar, x bar is 0, 0, y bar is 2r by pi. So by comparing 2r by pi and xr by pi, the value of x becomes 2. So very straightforward question. And one of those very rare questions that are this straightforward in JEE Mains. All right. Now we have understood the problem and the formula, which actually is all what you need in JEE Mains, is to know the very basic formula of center of mass for many of the figures. But if you are interested, and if you want to go a little deeper and understand how did we arrive at the formula of y bar of a semicircular ring being 2r by pi, then I would suggest that if you can do that, that will really enhance your your concepts in physics, and a couple of additional points that will come along the discussion. Okay, so if you want, you can follow the next one, or maybe skip the next solution and go on to the next the next problem. Now, if you actually follow the next question, that is again based on a very similar derivation. See, and that is the reason why I insist that you also give importance to the derivation of these formulas, so that things become really clear when a new figure is asked, which may not be the case as in the same one as in the given one here, where it is directly a formula being given to you. So even if something new comes up, you should be able to solve it. So I would suggest you follow the next the derivation, make a note along with me. If you're confident enough, feel free to skip it, go directly to the next question. Okay, so now let us discuss about the solution of this. Now let's spend some time, somewhere around 5 to 10 minutes, to understand the derivation of the previous formula that we discussed, which is y bar is equal to 2r by pi. But before that, the difference between a circular sheet and a circular ring. A circular sheet will have mass present within it, right? There is mass present within the sheet, whereas a circular ring has no mass present inside it. It is hollow inside. It has mass present only along the circumference. Here there is mass present in both the circumference and within it. Okay. So this would be the representation of a circular ring, right? So you can visualize a circular ring here, right? Now let us keep this circular ring in such a way that it is both symmetric to x and y axis. And how could that be possible? That can be possible only when you place this ring such that the center of the ring coincides with the origin of the Cartesian system, x and y plane here. Okay. After that, let us consider a semicircular ring or a circular half ring which is placed in such a way, being symmetric to y-axis and comprising of many small masses of dm1, dm2, dm3 respectively, which means we have dm1 here, right? And then we have another small mass dm2, dm3, dm4, and it repeats till we reach the complete half ring. Okay, and the respective locations, dm1 is at distance r1 from origin, dm2 is distance r2 from origin, r3 from origin, and then we have dm4 which is at r4 from origin, and maybe some maybe dmn which is at distance of rn from origin. Okay, now all of this is about origin. Just to make sure that you are able to visualize the concept well. So when we have a ring here, and while we consider dm1, right, while we consider dm1 alone, the distance now becomes distance about the origin, which is r1. The distance of dm2 about origin, right? dm2 about origin becomes what? Becomes r2. Similarly, we have r3, r4, r5, and corresponding distances which measures about the origin. Now this will keep on repeating till we get the complete mass, right? Till we get the complete mass. So maybe we'll get it like this. This is mass present here, here, and it goes on till we get this complete mass, right? So that is really important to understand. This process of adding up all these small elementary masses dm. Why is it important? because we have x bar is equal to sigma ri dmi by sigma dmi. What is sigma dmi? It means the sum of all these elementary masses. What is sigma ri dmi? It means ri r1 dm1 plus r2 dm2 plus r3 dm3 up to n terms. Okay. Now, at this point, you may come across a doubt. Some of us. So, you may feel that from the origin, there might be two different distances to be measured. The radius or Ri and Ro, where Ri represents the inner radius and Ro represents a slightly larger, the outer radius, because it is a ring. So yes, your doubt is, it is pretty much understandable. But what we assume here is that Ri is almost equal to Ro. It's approximately equal to Ro. What does that mean? It means that if you were to consider Ro minus Ri, if you were to subtract Ro, radius outer, minus radius inner, since they are approximately the same, the value will be equal to 0. Or in other words, what we have here is a very thin ring. I hope that makes sense. Okay. Now, once we have that, right? Once we have that, we can come to the derivation part now. So we have a uniform ring, which means mass is distributed evenly. It is placed in the xy plane. How? With the center being placed at origin. The ends of the wire lie on x-axis r, 0 and minus r, 0. It forms a half circle, and it is our aim to find the center of the mass of this wire. Right? Let us see how. So, to find this, right? To find this, we will use polar coordinates. Why? Because if not, if we use the regular method, right? If we use the regular method of finding the x bar, we'll have to make this calculation sigma ri dmi by sigma dmi, which is going to be very mathematically intensive, right? And usually when we have a continuous mass distribution, what do we use? We use the method of integration. And to do integration here, we'll first choose the polar coordinates. Now, what is polar coordinates here? Since the object is circular, it makes sense to use polar coordinates. How do we use polar coordinates? By converting x and y to theta. How do you convert x and y to theta? We assume x is equal to r cos theta and y is equal to r sin theta. Why? Basic definition of polar coordinates. You draw a triangle and then you take the theta measure, the corresponding x and y coordinate in Cartesian plane, right? Now, if we have x is equal to r cos theta and y is equal to r sin theta, what are the limits of theta? Something very important to understand. The rightmost point is r comma 0, which corresponds to theta is equal to 0, minus r comma 0, that is corresponding to theta is equal to pi. Yes, I do understand. You may have a doubt here. We will visualize it. Things will become crystal clear to you. So, we have a semicircular ring here, which has a radius r, which is placed symmetric to both x and y axis at 0, 0 being the origin, being the center, which means towards the positive x-axis we'll have a distance of plus r, and towards the negative x-axis we'll have a distance of minus r. All right, I hope that makes sense. Which means the x coordinate of this point here, say a, would be r comma 0, and the x coordinate of this point b would be minus r comma 0. Okay. So from the left to the, from the right to the left, the coordinates vary from x equal to r to x equal to minus r, x equal to plus r to x equal to minus r. Now, what is the corresponding variation of theta? See, d theta is the small angle which represents the polar position of a very small element of mass dm. All right, it's a very small angle. In which case we have this small angle here, which represents, or maybe this angle represents the baseline. Okay, so this represents the okay, this represents the baseline. Now, what is the position of A? Position of A is parallel to this baseline, which means theta here would be equal to 0. Now, what about the position of B? See, position of B, it actually rotates like this, right? Let me just use a different, okay, maybe I'll use this. So it rotates like this. It rotates like this, and it slowly arrives at P, which means the location of the angular location has traveled this far, which is equal to 180 degrees or pi radians, and therefore theta is equal to pi radians. I hope that makes sense, right? Write this along with me. Make sure you spend some time for writing as well, and while you write simultaneously while listening, it just concretizes your memory. Okay, right. So I hope you understand how do we arrive at the limits theta is equal to 0 to pi. If you've done that, let us now understand the center of mass. So we have center of mass is equal to x, the coordinates with x bar comma y bar, which is equal to integral x dm by integral dm and integral y dm by integral dm. Now to find out this, first we need to define linear mass density, which is uniform here, as lambda is equal to total mass by total length. What is the total length? L. What is the total mass? M. So we have lambda is equal to m by L. Now, what is the length here? See, for a circular ring, circumference is 2 pi r. For a semicircular ring, the circumference would be half of it, which is 2 pi r by 2, which is pi r. And therefore, the mass density can be written as lambda is equal to m by pi r. Okay. Now, what is dm? dm is lambda into ds. Why? Because lambda is a linear mass density which is constant throughout. Okay, so if lambda is equal to m by L, then lambda should be equal to dm by ds, the corresponding position of mass and corresponding mass and the corresponding position of mass. I hope that makes sense. Okay. Now ds is equal to r into d theta. Why? Because L is equal to r theta. Length of arc is equal to radius into theta, the angle subtended. In which case, what is dm is equal to lambda into ds? What is lambda? Lambda we have derived it to be m by pi r. So this becomes m by pi r into ds. What is ds? R d theta. R d theta. So r by r is 1. What we get is m by pi into, maybe I should write like this to give you better clarity. So this becomes m by pi into d theta is equal to what? Is equal to dm. Right? Now we can calculate the x center of mass or x bar. How? Because x bar is now equal to integral x dm by integral dm. Now, whenever we are discussing continuous functions, we need to specify the limits. We know the limits of x are minus r to plus r, right? So, integral x dm being integrated from minus r to plus r. What is x? X is r cos theta. Why? Polar coordinates. What is dm? We just derived it to be m by pi into d theta, right? So, substituting x is equal to r cos theta and dm is equal to m by pi into d theta. What is integral? Now how does the limit vary? Minus r to plus r. Minus r to plus r will vary from theta is equal to 0 to theta is equal to pi. So instead of minus r we have 0. Instead of plus r we have pi. Minus r 0, plus r pi. dm now becomes d theta. Right? I hope that makes sense. So, well, actually, it's x, the variable x, that is converted to d theta. Now, what is x? X is r cos theta into m by pi d theta. So we can take r as constant, r outside the integrand. Why? Because r is constant, m is constant, pi is constant. So we become rm by pi into integral 0 to pi cos theta d theta by integral 0 to pi dm. What is integral 0 to pi dm? It represents the what? It represents the total mass, right? Now, what is the total mass? The total mass is m. The total mass is m. What is integral of cos theta? Sin theta, varying from 0 to pi, which means Rm by pi into sin theta varying from 0 to pi becomes sin pi minus sin 0. Sin pi is 0, sin 0, 0. So this expression reduces to x bar is equal to 0, which makes sense. Why? Because the given figure is symmetric with respect to what? With respect to y-axis, and therefore x bar will be equal to 0. Right? And again, why should x bar be equal to 0? Because the center of mass will lie on the y-axis, and when the center of mass lie on the y-axis, that point which lies on the y-axis will have the x coordinate equal to 0. Right? Simple logic. Now let us discuss the y coordinate. Everything remains the same here. Instead of x bar, we have, instead of x dm, we have y dm. So y bar varying from minus r to plus r becomes 0 to pi. Minus r to plus r becomes 0 to pi, right? And one more time, why does this varies? Because as theta x equal to minus r, theta is equal to 0, and x equal to plus r, theta is equal to 0, and x equal to minus r, theta is equal to pi. Oh, I think I made a mistake here, right? Yeah, this should be the other way around. Sorry, my bad. X equal to plus r is 0, x equal to minus r is equal to pi. Okay. Now the derivation, how does it vary? Instead of r cos theta, we have y is equal to r sin theta. R is a constant, m is a constant, pi is a constant, can go out of the integrand. So we have rm by pi, right? We have rm by pi into integral 0 to pi sin theta. What is integral 0 to pi sin theta equal to? Minus cos theta, varying from 0 to pi. And, oh, my bad. Okay. And what is integral 0 to pi dm is equal to m, y, the total mass. What is minus? I'll just take this minus outside the brackets here. So cos theta varying from 0 to pi becomes cos pi minus cos 0. What is the value of cos pi? See, cos n pi is equal to minus 1 to the power n. So cos 1 pi will be equal to minus 1 to the power 1, which is equal to minus 1. What is cos 0? It is 1. So minus 1 is minus 2. Minus 2 into minus is plus 2. M by m is 1. So that we get is 2r by pi, and therefore y bar is equal to 2r by pi. Right? So this is what we have. So from these two, we can conclude that x bar is equal to 0. And we have y bar is equal to 2r by pi. Right? So that is how we arrive at the formula for center of mass of a circular ring as x bar is equal to 0 and y bar is equal to 2r by pi. I'm really sorry, the explanation was way longer for a very small derivation, but I just wanted to make sure that none of the steps are skipped and that you get complete conceptual clarity. So somewhere around 20 minutes, I do understand the pain in following a solution for 20 minutes and writing it down as well. But see, once you write this on your own, you can try the same approach for any continuous mass distribution. You'll be able to understand the way we convert limits from Cartesian coordinates to polar coordinates, and things will become really easy to you. And if you want to test the knowledge on yourself, then I would suggest try using this method to solve the next question on your own. And if you find it difficult, please feel free to write back. We'll do what's possible from our end. All right. So again, why did we derive this? Because the next question is pretty much based on not on the direct formula itself, but is pretty much based on the way of deriving this formula for semicircular ring, except for the fact that the question is based on circular ring. All right, so that's it with this question. Let's move on to the next one. Okay, maybe I'll just leave the integration part for you to write down. Right, give me some time. Yeah, so this is the integration. You can make a note of this.